Today we will go into Organic Chemistry, Chapter 14, An Introduction to Organic Chemistry. We will mainly focus on isomerism, and we will go into detail for structural isomerism, where under structural isomerism, we have three different kinds of isomerism, where we have chain isomerism, positional isomerism, and lastly, we have functional group isomerism. So we will go into details for three of them. So for isomerism to go, we can have actually two different isomerism, where we can divide it into structural isomerism and stereoisomerism. So first of all, let's go into the definition of them. So we have structural isomerism. So where for structural isomerism, the isomers or molecules will have same molecular formula, but different structural formula. So next to go, we have stereoisomerism. So for stereoisomerism to go, the isomers will have the same molecular formula and structural formula, but they have different arrangement of atoms in space. So today, we will mainly focus on structural isomerism. So where under structural isomerism, we have chain isomerism, positional isomerism, and functional group isomerism. So we have question in paper 2, where they will ask us for 2 to 3 marks to list down all kind of isomerism that we could have for structural isomerism. So we have to list down 3 of them. So then now, we will move into them in detail. So first of all, we will go into chain isomerism. So for chain isomerism to go, they are isomers with different structural formula, where the structure of it will have different arrangement of carbon atoms in chain. So basically, it's the length of carbon chain to be different in each of them. So let's make this C5H12 as example. So we could actually have isomer to have the carbon chain, the longest carbon chain to have 5 carbon. So the carbon chain will be in the way to have 5 carbon in the longest carbon chain. So the rest will be hydrogen. So this structure, we name it as pentane. So the next to go, we could actually arrange the 5 carbon in the way to have 4 carbons in the longest carbon chain. So we could actually arrange it in this way, and the 5th carbon, we just put it to the 2nd carbon. So we couldn't put the 5th carbon to the 1st carbon or the last carbon to go, because if we put it to the 1st carbon, it will be the same as what we have for pentane. So they are the same, because the longest carbon chain for this will be the same, where it has 5 carbons. So it is the same thing as what we have it here. So therefore, naming is the best way to know if they are the same molecule. So both of them with the same 5 carbon in the longest carbon chain. So they are actually the same molecule, which is pentane. So for this to go, we can actually name this. So first of all, we have to find the longest carbon chain. So the longest carbon chain is with 4 carbon. So the prefix will be bute. So it will be butane. And next to go, we will make this C as a branch. So if it is 1 carbon in the branch, we'll name it as methyl. So name for it will be methyl butane. But since the methyl is at the 2nd carbon, so the name of it will be 2-methyl butane. but the molecular formula of it will be the same as the first one, pentane, which is C5H12. So the next one to go, we could actually go for a molecule with 3 carbon as the longest carbon chain. So the 4th and the 5th carbon, we put it as the second carbon. So this is the 3rd isomer of C5H12. So let's go for the naming of it. So we will have the same thing here to get the longest carbon chain. So we have 3 carbons here, and there will be 2 branching. So where we have 2 CH3 at the first and second carbon to go. So we will name it as dimethyl. So both methyl is as the second carbon. So it will be 2,2-dimethyl prop, because the longest carbon chain is with 3 carbon pane. So name of it will be 2,2-dimethyl propane. So these are the 3 isomers or 3 chain isomer that we could get for C5H12. So next to go, we will go into positional isomer. So for positional isomer to go, so the isomers will have different structural formula with different position of function group in the carbon chain. So for example, we have here alcohol. So we could actually have the same chain isomer where the longest carbon chain with 4 carbons. And we can actually change the position of the alcohol, which is OH, in this carbon chain. So we can actually put it at the first carbon, the rest are hydrogen. So we could actually put it at the first carbon, 1, 2, 3, 4. And we could also put it at the second carbon. So we number it 1, 2, 3, 4. So they are the position isomer where they have the same function group, but they will have different position of the function group. So the name of this isomer will be butan 1-ol, since the OH is at the first carbon, and this will be butan 2-ol because the OH is at the second carbon. So let's go for the second example for this positional isomer. So here we have C3H6Cl2. So the functional group here is chloroalkane. So we can actually have different position of the chlorine. So we have different number for it. So actually we can have different number for it. And the name of them will be the same. So there will be dichloropropane. So we can switch the position of these 2 chlorine to have different positional isomer. So for these 3 carbon to go, we can only have 1 chain. So for 3 carbon, we couldn't have any chain isomer. But we can have positional isomer for the position of these chlorine atoms in this carbon chain. So we can have 1,1. So we can have 1,1 dichloropropane where both chlorine are in the first carbon. So we can actually number the chain with 1, 2, 3. So we can have 1,1. We can also have 1,2. So at the first carbon and at the second carbon. So we can also go for 1,3. So we can have the first carbon and the third carbon to have the chlorine atoms. So done with 1,1, 1,2 and 1,3, we can actually try for 2,2. So we cannot go for 2,1. It's because if we have 2,1, 2 and 1 is actually same as 1, 2. So that's why we don't go for it. We will go for 2, 2. So to have 2, 2, so it will be 2, 2 dichloropropane. So 2, 2, we will have 2 chlorine atoms at the second carbon. So we couldn't go for 2, 3. It's because 2, 3 is same as 1, 2. So that's all we could have for the positional isomer for this dichloropropane. So total we will have 1, 2, 3, and 4 positional isomer. So these are the example for positional isomer. So next, we'll go for the last one, which is functional group isomerism. So for functional group isomerism to go, the isomers will have different structural isomers with different functional group. So they will be totally with different functional group. So first of all, we will have this alkene and cycloalkene. Oh, there's some typo here. So it will be cycloalkene. So alkene. So we can have example where we have C4H8. So with this molecular formula, we can have an alkene. So for example, we can have C-butene. So this is butene. So then next, we can have a structure for cycloalkene. So we can go for a ring with 4 carbons, and we can name it as cyclobutane. So both of them will have the same molecular formula, which is C4H8, but they have different structural formula. I mean, they will have totally different structure with different functional group. So they are functional group isomer of each other. So next to go, we will have the second pair. So in total, we have actually 4 pairs of functional group isomer that we got to know. So the next to go, we will have carboxylic acid and ester. So let's make an example of carboxylic acid with 3 carbons. So with this structure, we will have C3H6O2 as the molecular formula. So with this molecular formula, we could actually have a structure for an ester. So this is a carboxylic acid and this is an ester. So there are different functional groups but with the same molecular formula. So this is the second example of functional group isomer. So let's go for a third pair. So the third pair to go, we have aldehyde and ketone. So let's make a simple example for them. So let's say we have an aldehyde with 3 carbons. So we will have C3H6O as the molecular formula. So we can come up with a structure with the same molecular formula for ketone. So this is an aldehyde and this is a ketone. So they are different functional group with the same molecular formula. So let's go for the last pair. So the last pair to go, we have alcohol and ether. So ether is actually not in the syllabus for us to learn in detail. But since we have alcohol here, so we will move into the functional group isomer of it, which is alcohol and ether. So let's say we have an alcohol with 2 carbon atoms. So the molecular formula will be C2H6O. So with the same one, we will have an ether to have the same molecular formula. But they will have different functional group, which is an alcohol and an eater. So these are the examples that we need to know for functional group isomerism. So total we have moved into 3 different kinds of structural isomer. So where we have chain isomerism, positional isomerism, and lastly here we have functional group isomerism. So they are all the examples of structural isomerism. So that's all for today.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.